Once upon a time, a group called Date Knight Rider embarked on a journey that would change their lives. The mechanical engineer Brandon constructed the car, the electrical engineer Zach constructed the engine, the bioengineer Ebo constructed the pump, and the civil engineer Nate constructed the bridge.
Group D8's RC vehicle is designed to move like a car in reverse. The front axle will be fixed, with power provided to the tires through that axle. The rear axle will be able to turn, but no power will be provided to it. The unique feature of D8's vehicle is that the body will be able to extend and contract through a set of gears. This will provide better handling and turn radius in unique situations. Here is what D8's mechanical engineering department has accomplished on the car thus far. I'm going to dive in and show you the individual components, how they work, and some tests I'm going to run. This is the front axle assembly in progress, and I'm going to walk you through all of the steps involved. So right here you have both of our axles and the axle casing. The motor is going to go through our body here and down into the axle casing, and it's going to power these two axles here. These are all 3D printed parts, PLA filament, and the axles are going to be able to slide with these grooves that you can see here with 16th inch diameter ball bearings. The wheel is going to attach to the axle by this shaft and groove, like so. Next is the rear body turning assembly. The turning mechanism will be powered by a servo connected to a turning arm. These wheel pins will be connected to the wheel, and as the servo turns, so too will the wheels. The back body will be connected to the front body by these shafts here.
For the CE portion of this project, the bridge was modeled in a program called Visual Analysis, where a load can be applied to any node to help calculate the deflection from that load. Using basswood members and 3D printed pin connections, the CE could construct the bridge, and using data from the ME, including the weight and width of the car, the bridge could be correctly modeled and designed.
Hi, I'm Zach Felsman, the EE of Group D8, and I'm going to provide you with a brief overview of the electrical components that will be utilized in our design. First things first, we will be utilizing the Adafruit Featherboard, which is low power and Bluetooth compatible for remote control access to the Adafruit phone app. Next thing is the DC motor driver add-on board, which will be utilized to control and move our DC motors, which is shown here. Another feature that needed to be included with our design was utilizing a servo, and due to the low power feature of the Adafruit Featherboard, I'm going to be implementing a pulse width modulator PWM add-on board, which will be able to achieve this feature. Both the DC motor and the PWM board will be powered with a 6-volt supply, while the Adafruit Featherboard will be provided with a 3.7 volt and 25 milliamp hour LiPo battery.
Swamp process begins in the main reservoir. Water in the main reservoir is pumped into swamp reservoir with the power of starter pump through pipe fittings. Fittings are used to decrease flow rate of water. When water reaches swamp reservoir, it also fills swamp, so the buoyant bridge will start rising up. To keep the buoyant bridge at steady level, some of water discharged with secondary pump to main reservoir. Secondary pump will activate it by car with using switch mechanism. When the buoyant bridge reaches the desired level, RC car can pass through swamp.